Good morning. I'm Bill Weinberg. I'm Senior Director of Open Source Strategy at Black Duck Software. Black Duck is pretty new to the security arena. If you've been around open source, especially in the areas of governance and compliance, you will have tripped over Black Duck during the last decade, during which time we've been helping people deal with the complexities of open source licensing and comply with the requirements of open source licenses. I come to Black Duck from an acquisition, actually, of a company called Alliance Group, which was, for a decade, a freestanding open source strategy consultancy in the San Francisco Bay Area, and I've been at Black Duck for around 3 years. We're going to talk about what we're calling open source hygiene today, which is mitigating risks by cross-referencing open source scanning, which is what Black Duck's specialty is. That's what Black Duck offers as a tool and does as a service, by cross-referencing those technologies with vulnerability databases. So this is just the abstract for when we put the presentation online. It's just a little bit about me. I've been working in open source for about 15 years. Started out as a user when I was working in embedded systems, both of user of open source tools, open source operating systems, and I went on at the end of the last century to be on the founding team at one of the first embedded Linux companies, Monte Vista Software. I was there for about 5 years, and then I went on to work for Open Source Development Labs, which today is the Linux Foundation. And in the meantime, I've done things like having a private practice for strategy consulting, technology consulting, and open source, and also running the Linux Phone Standards Forum and doing other things around mobility. We're going to talk about a couple things today. I'm going to give you some information that we've been gathering, we being Black Duck, about open source as it relates to general deployment and in particular security. Talk a bit about vulnerabilities and the landscape of vulnerabilities in open source. There's been a lot of, call it negative press lately about open source and vulnerabilities. Kind of show the reality, debunk some of the hype. Talk about how all this is relating back to the open source development model and the myths of that model, and then outline what we mean by open source hygiene. So first of all, open source is doing very, very well. So well that it's completely ubiquitous and no longer remarkable. I like to say that really there's no such thing anymore as proprietary software. Every type of software, every category of software, every host, every marketplace has dependencies on open source software, all the way up to being built 100% with it. Every year for the last 9 years, Black Duck has been collaborating with Northbridge Ventures, a VC firm, to do a survey primarily of vendors, but also of end users about how they feel about open source and where it's going. And a lot of this relates to the questions today about security. So in this last year's survey in 2015, which I happen to be the analyst for, they tapped me to work on it this year, 78% of respondents said they run their companies on open source software, which is an all-time high, and it's pretty impressive. And I will admit to the survey being somewhat self-selecting, but even with that consideration, it's very high. And other respondents, and we had around 2,500, 2,800 total respondents. We only took complete answers, so this is based on a cohort of 1,200 respondents. Only 3% of the companies responding said they made no use whatsoever of open source software. So while I was at Open Source Development Labs, we considered ourselves defenders of the faith. We were worried about open source surviving against the onslaught of proprietary software and ways of doing business. And today, somebody said to me the other day, you know, open source basically won. You see Microsoft loving Linux and opening portions of .NET, and everywhere across the industry, open source is there. It's no longer a novelty. It's completely mainstream. It's not used everywhere, but it's pretty close. Just if you look at our particular survey, since 2010, that's just in the last 5 years, the figure for people using open source or admitting to using it has basically doubled. And the funny thing about these numbers is they're actually very conservative. One of the things that Black Duck does is we go into companies and on request or as a matter of our regular business relationship, we scan their software portfolios for open source and for the licenses and for other information. And almost invariably, companies are underestimating their use of open source. We find of the companies that, of course, call us up, 93% of them are using open source extensively. It's not at all an unusual case. The way we work is that we collect information with crawlers primarily on open source projects. We catalog around 3,000 forges and repos out on the internet, and we end up having data for over 1 million open source projects. And while there's only 60 or so recognized open source licenses, which is our traditional point of focus, we actually catalog over 3,000 open source, self-styled open source licenses and related information. And the total abundance of open source just keeps growing, which is a good news, bad news dichotomy, because having open source everywhere is healthy. It gives people a lot of flexibility. It's a chance to innovate. But as we're seeing, it's also potential for a lot of vulnerabilities. Open source goes across every single industry. Every so often, I'll find a pocket where it simply doesn't play. Like I was doing a legacy migration project last year for a large aerospace firm, and they identified 4 silos that they wanted us to look at, one of which was semiconductor design. And there's really not a lot of open source in semiconductor design. But every other place they asked us to look, every other migration they asked for, had definitive, obvious targets that they could move to in open source. If you get excited, look at where the money is, where the excitement is around open source. These days, of course, it's in the cloud, cloud infrastructure, cloud application frameworks. It's in big data, starting with Hadoop. It's been in operating systems for several decades, starting with Linux and BSD, and now getting into OSs that are being deployed as part of cloud and part of the emerging Internet of Things. And that's the last area as well, is where and how open source is impacting Internet of Things and what the outcomes will be there. Now, this survey, the Future of Open Source survey, told us many, many things. It was a very comprehensive survey, but it revealed some interesting information on how end users of open source and IT people at large regard the security of open source. So first of all, we're finding that 46% of respondents look first to open source and think that open source is the place to go for security. And that is kind of the aggregation of 2 concepts. One, that open source software is more secure, and that if they're going to look for security tools, they'll look to open source on an equal footing that they will to proprietary software. Similarly, 55% said that open source software in general delivers greater security, which is an interesting number. It's certainly an impressive number, and it belies what I've heard in my experience over the years where I've had to defend open source as secure, mostly because people don't understand the open source development model. Now that's the good news. It's considered on a par with proprietary software, legacy software. It's considered very secure. But maybe that's actually occluding some issues and confusing people about how they should regard open source in their organizations. Because at the same time, 2/3 of respondents don't look at their open source portfolios, don't audit them for security issues. They just take them as they are, either, depending on their sensibilities, trust them blindly or hold their nose. But in either case, they're not monitoring their open source portfolios for vulnerabilities. And this is a serious problem. So let's look at the vulnerability landscape. The good news is that it's no worse than the rest of the industry. Open source is software like other kinds of software. It has a different development model overall, but it has been found statistically that it's exhibiting the same kind and same number of vulnerabilities as software developed in-house, software developed commercial proprietary software, other legacy software. Now, the big boys in the analysis game are worried about it. Maybe they're making a little too much noise. I mean, Gartner said that the defects publicly attributed to open source will increase significantly now, through 2020. Now, is that because open source will be getting worse or because open source deployment will be getting greater? And it really is the latter. If you look at the vulnerabilities just based on CVEs in the National Vulnerability Database, they're growing very fast. Last year was a banner year, and this year's already gotten off to a quick start. And what everyone seems to be remembering, at least in our neck of the woods, are the open source vulnerabilities that were part of this very large set of detected and published vulnerabilities. And that doesn't even go into the set that never got CVEs attached. So the kinds of vulnerabilities that we worry about, that we address, are the ones like Heartbleed and Shell Shock and Poodle, Freak, Ghost, Venom, the list goes on and on. It's kind of become a fad in the media to give these vulnerabilities cute names or to take the names different developers give them and to run around and be in sort of hair-pulling mode about them. And the one thing about last year was that there were 9,200 vulnerabilities reported, depending on, give or take 1,000, depending on whose database you use. And about 40% of them were in open source, which is better than 60%, but it's still a significant number and a number that needs to be managed. And the thing about open source is not only has it been a hype issue in terms of naming vulnerabilities, open source projects tend to be linked to one another very closely. There's a lot of interdependencies among open source projects. Some are worse than others. So when a vulnerability arises in something like OpenSSL, in fact, there's 30 or 34 vulnerabilities currently reported in OpenSSL, or when a vulnerability arises in something really core and basic like glibc, it impacts scores of other projects, entire platforms, and people's whole IT strategy and infrastructure, because open source is so prevalent in infrastructure software and utility computing overall. So it's not just something you say, well, it's an anomaly, it's just that set of software. We're not using very much open source software anyway, are we? And they almost always are. The prevalence, the hype around open source vulnerabilities became so great in the last 18 months that it actually made its way all the way to Capitol Hill and is part of pending legislation about supply chain. Now, for people working in open source, the good news is that in general, regulated industries and government agencies are now very friendly to open source. So DISA and the FDA and others have published policies. You can look at DISA's website to see how the military regards acquisition of open source. The FDA regards it on a par with other COTS software, but it calls it SOUP, software of unknown provenance, even though the provenance is actually often fairly easy to trace. But at least they're prepared to deal with it. But when we come to the notion of supply chain, there's legislation on the Hill with 3 key provisions. One is that third parties have to provide a bill of materials. Well, that's good news for Black Duck. We've been helping people do that for years. So this is actually good for our business. But it kind of scares the ecosystems, especially around multi-tier ecosystems in automotive and aerospace and defense. It makes their lives even more complicated. The idea that vendors can't use components if they know there's vulnerabilities in them. Well, that applies equally to open source and other kinds of software. And it is a solution to people just shutting their eyes and holding their noses and thinking, well, somebody upstream vetted this for me, or somebody downstream will vet it for me. And a very interesting provision is that software has to be patchable and updatable. Now, I come from embedded systems. I've probably been in and around embedded systems for maybe 30 years. And even though today we see use of real enterprise-class operating systems in a range of intelligent devices, even when there's Linux and or BSD and other real operating systems inside all sorts of gadgets, 70% of the gadgets deployed are never updated in their lifetimes at all, even if they're update capable. And so this is an interesting requirement, and it doesn't stand alone. Not only do you have to make them updatable in theory, you have to build a mechanism, a network to make them updatable in practice. Now, you're probably familiar with your phones getting updates and maybe some of your other home electronics giving you the options for updates, but this is a more rigorous requirement than what you typically see in the industry today. So let's look at the open source development model for a moment and understand why open source is or isn't more secure. Because there's a lot of mythology. I wouldn't say misinformation, but let's say, optimism and exaggeration about the upside of open source, at least where I come from, because I live in the open source bubble. And conversely, outside of that bubble, there's a lot of, let's say, misunderstanding and pessimism about that same model. So is it inherently more or less secure? Well, the basis of the open source quality model, development model, ultimately security model, is what's usually called Linus Law. And Linus Law actually wasn't uttered by Linus Torvalds. It was uttered by Eric Raymond, the author of such famous works as the Hacker's Dictionary, and more importantly for open source, the Cathedral and the Bazaar. And the idea is that given enough eyeballs, all bugs are shallow. Linus actually has a different law that's Linus's law. That's a different story. He talks about the motivations for survival and social life as motivations for coding and social coding. Different story. Now, open source manifests itself in a series of technology and community layers. And it's important to tease apart these layers to understand the development model and to understand the implications for security. So everything starts with code. And around the code are the core developers or the maintainers of an open source project. Around those, and those are the people who make the commits, who control the progress, who set the roadmap, who are sort of a mixture of lead engineers and project and product managers in a traditional corporate setting. Around those folks are people that constitute a developer community. And those are people who are actually making contributions to the code itself. They may be reporting bugs, they may be making feature requests. More often than not, they're submitting patches. They're active end users. They're people that care. Open source, to be effective, is said to have to scratch an itch, and these are the people that are itching. They're the people that adopt the code, inspect the code, make changes to it, and work actively with it. And then the final ring around that are, let's say, casual end users or functional end users and the commercial ecosystem that accompanies them. These are not people who are really making concrete contributions, but they are using the code and often exercising it in novel ways, bringing out corner cases. And it's the interaction between these different layers and these different communities that makes open source very effective, makes it fast, and in theory gives it a superior level of robustness and security because of the overlapping interests and type of use cases and use models. Now, with relation to security, with relation to feature advancement, with relation to just evolution, what happens is from version to version, these different communities are making feature requests, reporting vulnerabilities, reporting bugs, all the different outcomes of actually using software, integrating software, depending on the industry you're in. And the project leads, together with the development community, create new versions that have fixed the bugs, that have added patches, that have added new features over time. And of course, just like any other engineering organization, the project leads have a distinct tension between fixing bugs and adding features. And so the good news is that the classic mantra of open source is release early, release often. And so open source moves along at a much more rapid pace with incremental releases. Sometimes they're experimental, sometimes they're mainline, and it has resulted in a very rapid evolution of open source and presumably a rapid advancement in the quality and security of the software. Just an incremental improvement. So if we look at the many eyes aspect of this, the community is watching the code. Primarily it's watching the code for basic code quality, code style. It used to be funny, when I was at Monte Vista, our customers used to ask, oh my God, do I have to hand that back to the community? Do I have to publish that? Do I have to submit that? And the basic answer, if I was, depending on the mood I was in, the mood we were in, was, well, no, here's the rules for it, and here's the license, and it depends on the license, it depends how you're using the code, and it depends if you're releasing the code. But under my breath, I was thinking, you should be so lucky. Most patches, most feature requests are completely ignored, and the communities around the projects move on at their own pace. Most people's feature requests don't make it into the main line. It has to be a logical change, it has to be a reasonable patch, it has to be well structured and well documented. And even when I was working for companies who were doing real solid work in open source, more often than not, the maintainers, especially of the Linux kernel, would take our patches and totally refactor them to the point where we weren't even able to recognize them. We were lucky if we got a line in one of the contributors' files. So this is how it's all supposed to work, and in many cases, this is how it works, with an emphasis on code quality, code style, which varies a bit from project to project, certainly. There's also another defense mechanism against errant code that a lot of people don't think about. And I affectionately call it the triple fence in memory of what the NSA used to say about itself. But the fences are a bit different with open source. The first fence is that of the people running the project. Now, did they let in funky code? Do they accept patches that shouldn't be there? Do they accept suboptimal code, badly written code? And so that first layer comes from how mature the project is, who the maintainers are, what their focus is, how many of them are there working on it. And so that's where the primary defense comes from, and that's what determines the character of a project. And in fact, at Black Duck, we have a free public tool called OpenHub, that used to be called OLO. If you want to learn about the attributes of a project, just go to openhub.net, type in the name of your favorite open source project, and you'll learn a lot about who the developers are, how often they're releasing, when patches were released, how many have been released over time. It's a very useful research tool, and certainly useful for assessing the maturity and indirectly the security of an open source project. The second fence has to do with aggregating other projects into a platform or distribution. So whether you're talking about folks at Red Hat, or Google and its community building Android, or embedded Linux distributors, or any number of people that are creating a platform, they're bringing together packages, bringing together other functionalities to create a platform that they're going to sell or distribute. And they're doing a certain amount of vetting. They're choosing, one would hope, the best-in-class projects. They're looking at the attributes of each project. They're picking the best, most stable versions of each of these projects to create the best and most stable platform. That's the second fence. And the kinds of testing that they're doing are totally different from what the applications, the original developers are doing. And in fact, it's their job to productize open source. And so they're running things like regression tests and standards tests and other things that practically no one else in the industry does because it's their job to do so. The third fence is really one of end users, OEMs, and integrators, the people that pick up the code and use it for something. So whether you're running an enterprise, building your business on open source, whether you're building a device, or whether you're a company working as a third party doing that for somebody else, you're taking all this code and you're putting it together into a functional grouping. And again, you're doing tests and exercising the code in ways that are unique to that particular task, to building whatever the end product or end service is. These three fences together result in very high quality production code, and one would hope, one would think, more secure than not production code as well. Now, the challenge is that while many eyes do make bugs shallow, not all of those eyes are security savvy. In fact, very, very few of them are. That's not what the goals of most projects are. They're about getting high functionality out to market quickly, whether it's in a commercial or non-commercial setting, and they're occupied elsewhere. They're occupied fixing regular bugs. They're occupied taking feature requests, all the things that you do in software engineering. And while code quality contributes substantially to security vulnerabilities, it's not the only contributor. And if you're not testing for security, which most of these projects are not, then you're not going to get necessarily more secure code than you would elsewhere. And so the community can be increasingly blind to security issues. And the perception that open source is more secure is a marginal one. And even if you follow the logic of Linus' law of many eyes, there's lots of threats that are simply resistant to oversight because they have to do with real implementation and how code gets used in actual application settings. So certainly misconfiguration isn't going to show up in most cases because it's outside the purview of the developers. Network vulnerabilities, deprecated versions, which is one of the things that we're worried about doesn't show up, and so on down the line. There's myriad faults that have nothing to do with the original development effort, but have to do with the real use cases and with other kinds of threats that are not at all part of the development model. To address these problems, we at Black Duck have put together this notion of open source hygiene. And I'm not flogging a product, it's more of a concept. It's embodied in some of the products we make. It's something you can do with all sorts of other tools, and in fact, you can even do it by hand. Let's talk about what it is. Well, it's very much component level, and is very much related to the vulnerability landscape at large. We chose the term hygiene because we're trying to keep the code clean. We're trying to scrub open source code. And we're not talking about this kind of open source hygiene. It's not washing our favorite animals. It's very particular. It's cross-referencing the content of your company software portfolio, the open source content, against known vulnerabilities. And that's non-trivial. It sounds like, well, that shouldn't be very hard. I'm only using 3 libraries, and I've checked the databases, and I know that there's 7 vulnerabilities logged against them. We're done. That's not really what happens. The people that we talk to are using thousands upon thousands of open source components, or at least they are after they do some scans and get an idea of what's in the box. And thereby they're looking at hundreds, or in some cases thousands of vulnerabilities potentially logged against them over time, not just against the current revision. It's very important that open source hygiene be practiced on a component by component and version by version basis, or it just doesn't work. Now, from a marketing standpoint, I'm always asked, well, where does this fit in? There's a lot of different categories. I sat down and looked at a paradigm of all the different types of security products that are out there. Remember, we're just getting into this marketplace. A lot of us at Black Duck have experience in security, but the company has primarily been involved in governance and compliance for the last decade. Well, it turns out, we're really focusing on the center here. It's a cross-section of code quality, of update and patch management, of policy enforcement, and configuration management. It's those things together that we look at. And it turns out that in the last 12 months or so, both Gartner and Forrester have invented a new name for this particular intersection, independent of whether it's open source hygiene or not. They're calling it SCA, Software Composition Analysis. I have no idea. Is that a familiar TLA to anyone in the audience? Raise your hand if you know it. I didn't think so. It's a Gartnerism as far as I'm concerned, but we'll see where it goes. So what really goes on here is that either by using tools that we supply or by using the output of continuous integration tools, or there's a whole bunch of ways, people are generating bills of material. That bill of material may or may not be sufficiently comprehensive for the purposes of really doing open source hygiene. I used to consult for a company called Embedded Alley. They were later acquired by Mentor Graphics. And even their little tool set, it was just a consulting services company, they would burp out a bill of material for all of their builds, but it was sort of a top level. It wasn't very comprehensive. And that's what a lot of other tools will get you. Whatever level of bill of material you get, at the very least, you want to know the name of the component, and you want to have the ability to determine the version to make all of this work. Because what you're doing, well, you're basing this on the assumption that newer is more secure, that newer is better when it comes to security because patches have been applied. It may not always be the case, which is why you should always accompany the process of open source hygiene with some additional research. But the assumption is that against some of these components, there will be vulnerabilities and even exploits logged in some of the popular databases or through other means. Now, we start out with the National Vulnerability Database that we draw from. We are also bringing in information from OSVDB, which makes a lot of sense. The two complement each other very nicely. And we're also working with our friends at RVAsec to add commercial database information to further flesh out the level and depth of information on vulnerabilities logged against different versions of the software. We do very comprehensive scans to figure out the version, but for us, the original motivation for caring about versions is that in open source, from version to version, the licensing terms can change, and that's what our customers originally cared about. So we're very strict about that kind of information. Now, where do you do it? Well, it doesn't really matter whether you're talking about waterfall or CI. We have customers doing fairly traditional waterfall who are doing hundreds of builds a day, massive scans. They put our premises software in their build engines. We have other people that are adding this functionality to continuous integration schemes. So This diagram actually came from a webinar that I did with T. Rowe Price back sometime last year. And this was the arrangement of how they set their stuff up around Jenkins. They were using Subversion as their repo and an Artifactory for the other artifacts for managing them. And they were just trying to walk through the flow. And originally we were talking about, well, where does governance fit in? But it's equally interesting as to where their open source hygiene fits in. So first of all, if you're going to be applying open source hygiene, you're going to have some buy-in from the developers. And that's always a challenge in that the average developer doesn't like to deal with security, doesn't like to deal with policy, doesn't like to deal with governance either, which has been a cross that we've borne for a while. But at the most basic level, if you're using scanning tools like the ones we provide or the ones that anyone provides, you can get stuff like this out of Git for that matter, you're going to be scanning the repo for the actual components that make up your project, make up your build, and it has to be a very thorough scan. And you're not always, depending on how the repo is put together, you may or may not be able to retrieve version information, but it's very important that you do. Certainly you can be triggering this automatically. Doing it in the repo is usually something you do on demand as part of an audit exercise. Doing it as part of your build is the best way to do it because processes like this only work if you don't disrupt existing workflows. So it's best to build them in to whatever processes you already have in place. And in fact, what we're doing, what we're doing is we're actually going to be offering a plugin as free software. Well, we'll see what license it's under, but freely accessible software, so that you can do this with a plugin to Jenkins itself. It'll be available in the Jenkins marketplace, and it'll be able to tell you, for example, which of the components in your Jenkins generated BOM have vulnerabilities in them and what their severity is. Now, our goal is not to supplant security testing. We know that open source hygiene is a relatively narrow discipline. It's part of AppSec. It applies to open source code. It doesn't really help you with your whole portfolio, but open source is often the big black box in people's overall organization, their technology portfolio. So the difference from our point of view between what we're doing and what a range of traditional security testing does is that we're trying to integrate this further and further back in the application lifecycle. And so all the way back to the analysis stage, we're already working with people to build governance strategy and governance policy, and so it's very logical that they'd be building their security policies in at the very same time. Similarly, at the design phase, they should be consciously selecting their open source based on governance and licensing issues, but at the same time on security considerations and so on down the line. We're very much convinced that this process will not work unless it's thoroughly integrated into the development lifecycle, whichever particular methodology you're using. Now, it's not easy. It seems like it's a very simple association between a component and vulnerabilities and which database you look in and which one you choose. But there's a lot of technical and social barriers to making it work. So on the technical side, simply the schemas in the databases are not consistent. They're not immediately parsable. They don't always map cleanly back. Version information can be obfuscated both on the bill of materials side and on the database side. If you don't build it into the workflows, it's harder to use and people don't use it. A big challenge is the scan speed. So if you're not doing continuous integration and making the assumption you're only scanning deltas, if you're scanning the entire corpus, it can be quite challenging and quite slow. And so you need to have tools that move fast enough to make this worthwhile. And we're talking about, in some cases, code bases that have 40 million lines of code in it. So it's a non-trivial operation. DevOps, it can be a little easier. The issue, of course, is how many builds are you doing a day? How many builds are you doing an hour? How many builds are you doing simultaneously in an organization? And certainly being able to scan comprehensively is a real problem. I mean, there's a lot of code. There may be multiple repo locations. You may not even know where all your repositories are. Having proper language support. Our compliance tools scan for like 16, 20 different languages. But our security tools, which are just starting out, only scan for Java because we've been pulled into this by our financial services customers who basically only program in Java, only use Java. But we're expanding very shortly to address, for example, our technology customers who program in C, C++, and everything else you can think of. A big challenge is we find from our governance processes that open source doesn't just show up in neat chunks. People modify it. You have to be able to identify the modified code. But even more radically, developers will pick up pieces of open source code from one project and slap it into the middle of their proprietary code. We call that snippets. For the purposes of intellectual property management, you have to find it because it's subject to the same licenses. And if it's a big enough snippet, even if it's not that big a snippet, it's probably also subject to the same security constraints. So being able to do very comprehensive scanning is very important. And again, missing versioning, information like that. And it's something else you don't consider with open source very often is that, yeah, you want to start out worrying about source code, and our knowledge base is all about fingerprinting source code. But in many contexts, especially with a supply chain, your open source is being delivered to you in binary, and you need to be able to make the same recognition in binary. And there's a project in open source called BAT, the binary analysis tool, that we're actually now contributing to and thinking of integrating into our offering as a way to scan binary as well, and if we can enhance it somewhere up near the level of what we do in source code, it would be a good thing. On the social side, certainly we find companies who, from our point of view, have suboptimal management processes for their open source code. And that will apply to management for governance and management for security as well. The real challenge is that most developers, a lot of architects, organically select their open source. They're not going from a whitelist. They're not consulting a blacklist. They're not considering anything but whether that piece of code actually fits the functional requirements for the use case they're making, which is a nice technical approach, but really doesn't take into account the community dynamics and the security of the particular component involved. And a lot of companies have industry norms that are incompatible with securing the code, like I talked about embedded systems overall, or they simply can't or they won't remediate. There may be architectural issues that prevent remediation. Just the code doesn't fit. They may have version dependencies on a back rev and deprecated code. They may be using their own forked versions, which can't be easily remediated because they've made so many changes or they haven't documented them. And then, of course, they're all suffering from different kinds of warning fatigue. So remediation, of course, is the result. We actually have a practice called Remediation Strategy for all kinds of remediation. We don't do it ourselves. We sit down with a code base, we look at how it's been scanned, and we help our customers decide how they want to go about remediation. Sometimes we actually participate in it, but usually not. We're just giving them advice on the most optimal way to do it. And each industry we found, and this is actually from OPSEC, has different remediation practices and how long they take to remediate vulnerabilities. So, cloud infrastructure is the fastest. Takes them only 50 days on average to make a remediation, whereas educational financial services are the longest, average 176 days apiece. Why? Well, sometimes it's because they're in a regulated industry, but regulation cuts both ways. The people in financial services say, we can't remediate quickly because our regulations require we do extensive change management. And the people in healthcare say, we have to remediate quickly because we have to fix the bugs because it'll threaten a patient's life. And so the same excuse can be used with different dynamics attached. There may be dependence on particular metrics. There may be dependence on particular descriptions in CVSS. There may be too simplistic an explanation. They may be misled by an explanation. And certainly an interesting factor that was highlighted in an article recently is that exploits tend to be greater and more accessible for vulnerabilities that are publicized in social media channels. There's a direct correlation between exploits and tweets around a given vulnerability. Our mantra, our best practices are that you identify, remediate, and control. This is sort of our marketing literature, I have to admit. But the idea for whether we're talking about governance level remediation or security level remediation is, know your code, pick your remediation path, and then don't so that it's an ongoing effort. And we find again and again, we come back into our customers and less than a year later, they really haven't changed anything. They took the output of whatever we helped them do, they smiled, they distributed some information, they updated their policies, and then the rest was business as usual. And I'm not going to go into triage considerations in detail. Most of them are really the same as for other kinds of software. But the big factor in open source comes down to whether a company is willing and able to maintain a fork within their own organization. And we find this varies greatly with different kinds of organizations. But if you're taking a patch or refusing to take a patch, if you're making your own changes to the code as part of remediation, you have to take into account whether or not you ever want to send this stuff back upstream, whether you're capable of it, what your relationship is with the community around it. That's probably the most unique part of open source remediation that you don't see with other kinds of software. Now, a quick plug for just how you do remediation, how you do automation in OSS Hygiene. And while it's possible to do it manually, it's much better to automate it. There's just too much code involved. Getting it done in time is a real problem. If people are doing remediation by hand, they do it once every quarter. Or, excuse me, open source hygiene, maybe they'll do a scan and analysis once every quarter. They'll just look at it whenever it's convenient, whenever they have spare cycles, which is equivalent to saying never most of the time. Well, that's why automation is important. The accuracy of manual scanning is very, very low, very problematic. Nice thing about it with tools, it's a lot higher. Doing it comprehensively is very important. Latency, of course, I mentioned. The amount of time spent doing one and getting to the next one can be weeks or months. With an automated process, the latency is seldom more than hours, especially if you're relating the vulnerability detection back to databases, which can be updated hourly, some of the better ones. Usually doing the work by hand isn't traceable, it's not repeatable, and the remediation is usually very subjective. Automating remediation on top of OSS Hygiene means it's repeatable because it's policy-based. The cost, well, it depends where you want to spend your money. Doing it manually is usually quantified in terms of FTEs. Automating it may come out of either a CapEx or an OpEx budget. These are just some screen caps of different tools that are available to do it, the kind of things, the way stuff gets called out. Ultimately, it looks like a dashboard. If it's good, you can actually go into it and point and click with different tools to find out about the actual nature of the vulnerability, get the CVE, get real information on it. You know, we're providing a dashboard as part of a product that we're calling the Hub. Look out for this report generator that we're going to be offering as a plug-in to Jenkins shortly. The thing about OSS Hygiene, as we call it, is that it brings the components up to date. It opens up third-party code, which you often can't look into or don't think about looking into. And it's about fighting version deprecation and version proliferation. But of course, it's only as effective for security purposes as the latest revision. So if a project hasn't been updated in a while, or if the current updates don't actually fix the bugs, it is what it is. Open source progresses the way it does. And it's only working for open source, although some of the methods could be applied to proprietary software, or if you're practicing this new discipline called inner source, where you treat your internal development like it's open source, then you can actually apply the same tools and methods to work you're doing behind your own firewall. And it's a source discipline, but we're trying to extend it to binaries as well by working with BAT. So the idea here is we're addressing a critical function in AppSec with open source hygiene. We're not making any claims that open source hygiene is something magical or special. It just takes source code analysis tools and it applies a mix of community and vulnerability information. It's not a replacement for other kinds of security tools. It's not a marketing gimmick. It is actionable methodology and technology and can be implemented by hand, but just make sure you have the resources to do it, or with automation. And it certainly benefits from using computer technology at all levels. But it's only really best employed if it's part of a larger open source management and security paradigm. And I made it in under the time. Does anybody have any questions? All right, well, thank you for your attention today.